1, 2, and 3 aren't bad. 1, 2, and 3, you're basically just translating it. There's not really a lot of work to do. You just got to convert it into radical form. Remember, the denominator is going to be your index. So when you're writing it on your paper, you need to make sure that you write it so it's obvious that it's an index. Okay, I've seen some where you have the 3 and then it's not the right thing. You need to make it obvious that it's the index for that radical. The numerator is the exponent. We won't write 5 to the first. We'll just write 5. So that's all you really have to do for 1. 2 is pretty much the same way. You have a fifth root of 6 squared, which we just write as 36. So if you want to show that step, 6 squared, so the exponent on the 6 is the numerator, the index is the denominator, and then we just expand out to 6 squared, 36. Okay? Number 4's got a lot more going on. Because we have an exponent on and inside parentheses, and another exponent outside parentheses. This can follow the power to a power rule, but they also want it to be written in radical form. Okay? So I'm going to go ahead and follow the power to a power rule first, and this would become n. And when you multiply the exponents, 3 times 2 fifths is 6 fifths. You got to make sure you know your fraction rules. When you multiply fractions, when you add fractions, you know how to do that correctly. Then if we want to translate this into radical form, the denominator is our index, and 6 is our exponent. But if we have at least, since the index is 5, if we have at least 5 of something under the radical, we can simplify this more. Because this can be written as n to the 5th times n. Just like when you have like basis, you can add the exponents to get the result. You can break it apart the same way. And this into the 5th can come outside the radical, and he will lose his 5th root, and this n will stay underneath. So that would be the simplified version in radical form. Radical form back to exponential form. Now 79 is prime. And if I could break it down some, I would, but I don't think there's anything that goes into 79. I tried to think through it as much as I could, use my calculator some, but I don't think anything goes into 79 besides 1 and 79. So if it's prime, can't break it down, then the index is not written, and neither is the exponent. So if they're not written, they're understood. If they're not written, they expect you to understand what they are. This is a square root, and that's 79 to the first. So it would be 79 to the 1/2 power. That's all you really would have to do. If it's not written, it's index of 2. Just like if it's not written, it's an exponent of 1. 153. Does anything go into 153? I don't think so. Oh, it does. It does. Good job. So 153 is 3 times 51. And 51 is prime. Is it? 51 is prime. So we're still stuck. I mean, we could try, but you need to have at least 4 of something to get anywhere. Because we're an index of 4. Okay? So 3 squared times 17. So even then, though, we're going to convert it to exponential form, we could write it as 3 to the 2 fourths and 17 to the 2 fourths. No, 1/4, sorry. And we could write that could be 3 to the half, because 2 fourths reduces to a half, 17 to a fourth. I guess that would probably be the best way to write it. Or you could put just 153 to the 1/4. Either way. What about 7? We look at, we got to remember we're going into exponential form. What do you think? We need things divisible by 3. We need exponents divisible by 3. 6 is. Yeah. It might help you if you break each of the factors down. Let's just focus on cube root of 27, and then we'll focus on cube root of n to the 6th, and then we'll focus on cube root of n to the 4th. Because if they're all multiplied, you can break them up. And then we have smaller problems to deal with. 27 is 3 to the 3rd. 3 is 9, 3 times 9 is 27. So if that's cube root of 3 to the 3rd, this would be, this would simplify. This won't simplify. I'm gonna hold on before I convert it over. I'm going to convert it over to exponential in the next step. This would simplify to cube root n to the 3rd times n. Because I need to have, if this number is bigger than that number, I need to probably do some simplifying. So when I convert it to exponential form, this would be 3 to the 3/3 power. This would be m to the 6/3 power. This would be n to the 3/3 power, and n to the 1/3 power.
Could the first one just be 3 to the first power?
And that's what we want to do in the next step. We want to reduce those exponents as much as we can. So this is just 3. That's m squared. That's just n. And that's n to the 1/3. Now, I think it's okay if you didn't break this up, the ends. I think it would be acceptable to leave it as, when it's in exponential form, to leave it like that. I think either one of these would be okay. Of course, take out the dots.
You just want it as 3n, the one that's...
Here? Yeah. L-M-N. Good. A lot of times they want it in alphabetical order. Oh, and get rid of these? Or just to start with?
No, I just mean like put it as 3n m squared m.
You could. Number 8. Even if you break it apart, and I'm going to break it apart and convert it to exponential in the same step. So it's 2 to the 1/5, a to the 10/5, b to the 1/5, two doesn't break down. That's going to be an a squared. To the 1/5, b to the 1/5. And you could put those together in the same 1/5. Either way. So 9. 9 is 81 to the 1/4. Now, 81 is a prime number. In fact, I'm sorry, it's not prime. It's a perfect square. Right. In fact, it's a perfect square of perfect squares. That's kind of cool. Yeah. So, not only is it 9 squared, it's 3 squared squared. Or just 3 to the 4th, right? 81 is 3 to the 4th. Test in your calculator. So if you have 3 to the 4th, that's equal to 81. 2 to the 1/4 power. And what happens to the exponents? 4 times 1/4 is 1. Twelve and 13, I want to go ahead and do both of those because they're a little bit different. One has the negative sign on the 256, and then the 3/4 is right on the 256, and 13 has the negative sign in parentheses to the 2/3 power. So this means the 3/4 is only on the 256. This means the 2/3 is on the entire negative 64. So this could be written as -1 times 256 to the 3/4. And then I can evaluate this and then put a negative on it at the end. Over here, I have a negative 64, which could be written as a -1 times the 64 to the 2/3. And then the 2/3 could go on the -1 and on the 64. So you see the difference? The 3/4 is not on the -1, but it is, the exponent is distributed to the -1 there. It may not make a difference in the answer, but it could. It depends on what exponent it has. Over here, -1 to the 2/3 power is what? Let's look at it in radical form. That would be -1 squared cube root. What's -1 squared? +1. -1 times -1 is +1. And the cube root of 1? 1. So we end up getting 1 times 64 to the 2/3. What is 64? 2 to the what? 8 squared. And 8 is 2 times 2 times 2. So it's 2 to the 3rd times 2 to the 3rd, which is 6. So 64 is the same as 2 to the 6th to the 2/3. 6 times 2/3, 12 over 3. So we end up getting 1 times that, which won't ever change it. Yes?
Wouldn't it just be easier to put it,
All right, let's go to the back. Okay, 15. 18 and 19 are actually really, really easy. They're really, really easy. So try to understand and get the easy ones right. Okay? They're easy because when you have like bases, you're able to add the exponents. And in this case, the exponents are fractions and they already have a common denominator. So that makes it nice. So that's equal to G to the 4 plus 3 over 7, you're adding your exponents, which is just g to the 7 over 7, or g to the first, just g.
So you don't multiply the G's either, you just do it.
No. Adding the exponents takes care of the multiplying the g's. 22 is not a trick. We can't simplify that. If the numerator was bigger than the denominator, maybe we could. But there's really nothing you can do there besides maybe change it into radical form. And even then, you should be able to see that's 5th root of b to the 3rd. That's not going to go anywhere. Nothing's going to happen there. 23, just like multiplication with like basis, we added the exponents. In division, we would subtract the exponents. So this would be q to the 3/5 minus 2/5, which is 1/5, or 5th root of q, whichever you prefer. So we have a lot of t's. We have a 5 down here. The 5, I'm just going to get him off to the side as a 1/5, and then I'm focused on the t's. Dividing by 5 is the same as multiplying by 1/5. Now we have a t to the 3rd, or t to the 2/3 in the numerator, and then we have a t to the half and a t to the negative 3/4. So we're going to be adding and subtracting these exponents to get it all, figure out what t's exponent should be in the end. These two, when you add them together, when you add the exponents together, a half minus 3/4 is what? Negative 1/4. But I mean, negative 1/4. So if we have t to the 2/3 over t to the negative 1/4, we would want to subtract those, but one is a negative, so when you subtract a negative, it turns to a positive. So 1/5 times t to the 2/3 plus 1/4. Now, how are we on adding fractions with non-common denominators? Okay, well, let's see. 25. Now, got a little issue here, because in the denominator, it's not just one term. Like here, it was all multiplication on 24. 25, it's not. So if it's not one term, and I'm trying to get, because my rule is I can't leave a fractional exponent. If it's not one term, how am I going to get rid of a fractional exponent in the denominator? Multiply by there's a word for it, there's the C. We haven't talked about it enough. Conjugate. That's it. Conjugate. So the conjugate of 7 to the 1/2 minus 1, that's right, z. Z to the 1/2 plus 1. Just see if you're paying attention. Over itself. And so when you FOIL that out, you'll get rid of any exponents that are fractions in the denominator. Yes. Because z to the 1/2 times z to the 1/2 is just z. Z to the 1/2 plus, times positive 1, and then the z to the 1/2 times negative 1, those will cancel each other out. And then negative 1 times positive 1 is negative 1. FOIL it. You FOIL it correctly, you'll get that. In the top, we don't have to FOIL because we have a monomial and a binomial. So we need to just multiply 2z to the 1/2 times z to the 1/2. What do you get? Yes. Which does what to the 1/2? We add the exponents together. 1/2 and 1/2 is a. That takes care of that part. Then we multiply by the other term, and it doesn't change any. Multiplying by 1. On 26, I think you can do 26. I must get 26. You can do that one. Square root of 12, we don't know, but that's 3 times 4, which is 3 to the 1/2, 4 to the 1/2. 4 to the 1/2 is 2. Square root of 4 is 2. Fifth root of 12 to the 3rd is the 5th root of 4 to the 3rd, 3 to the 3rd. Which is 2 to the 6th. This is 2 to the 6th. Four is 2 squared. 2 squared to the 3rd. 2 to the 6th. So this would be 2 to the 6/5, 3 to the 3/5, and the ones with the like bases can add their exponents together. 1/2 plus 3/5. What's 1/2 plus 3/5? What is 1 plus 6/5? What? Where do you live? On Jackson?
Bob White. It's like right off of Jackson.
Cool. Come on over.
You moved?
Yeah.
Hey, you're not that far from me either.
Great. Can't wait.
I know.
I'm so excited.
You too?
Live in the city.
City.
Live in the city. Yeah. Or where you live? Or where you live? Like,
Like I saw the paper last, like I think they're generally.
moving. Where? In the process yeah, that's what my trailer. Animals or dogs. They're up all night. Barking all night.
About like, I wanna say, second part of like.
I wasn't here Monday. We had 4 hours after the party. We supposed to meet tomorrow. No, we literally.
Good morning, Friday High School. Will everyone please rise for our pledges and a moment of silence? I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Honor the Texas flag. I pledge allegiance to thee, Texas, one state, under God, one and indivisible. And now for a moment of silence.
But why?
Like trying to cut off.
Thank you all so much for your attention. So this morning I found out the girls basketball team really beat Houston badly, 50 to 25 last night, and they now head to the final result. We will let you know when
How's it going?
Soccer, the soccer boys won 2-0 last night versus Lockhart. We had goals from Alex Gutierrez and Joey Helton. JV soccer also won 2-1 with 2 goals from Danny Hernandez. So they play at home again this Friday against Dripping Springs and go out in show them some love. Girls played hard, but unfortunately lost one to them. And the district play, it starts this Friday at Thursday through Wednesday. Those girls are still fighting for the heart to stay in the playoff spot. Girls, you can do it. We are cheering you on. So there is no drama club this week. They hope to resume next week on Wednesday in the library, which is not campus partners. I'm looking forward to that. Students who received an NHS packet, please listen. Your application is due Monday at 7:50 in room G209. That's Miss Duncan. Late applications will not be accepted. Do not plan to submit your essay electronically. You can stop by and see Mrs. Duncan if you have any questions. And also, it is PAL application time. So you know what PAL is?
I tried yelling at you the other day. Because I had to recall this.
And when you're service-minded and you would like to be a PAL, please apply at G220. Those applications are due this Friday. Students that have applied to San Antonio College for dual credit courses in English 4, accounting, or BIM for next year will be able to take the CSI test next week on Tuesday or Wednesday. Students must see Mr. Milner to sign up for a slot on one of those 2 days. You have until this Friday to see Mr. Milner to do so. AP students, listen up. AP exam registration closes in just a couple of weeks. So turn in your completed forms and fees to Mrs. G in the counseling office as soon as you can if you are wanting to take that AP exam. And again, if you're interested in trying out for Golden Girls or Sapphires, pick up a packet up front. That mandatory meeting is on Monday at 5 in the library. And try out practice for cheers next week as well from 4 to 6 in the gym. Thank you all so much and have a wonderful day.
Okay, get a calculator? And get your picture out.
Yes, I use those kind of words like hurry up, baby. What you gonna do? What you gonna
Okay, so the calculators are going to be only you and someone from fourth period, maybe, are going to use that calculator. First and fifth period algebra 2, they're not going to use calculators for the next week and a half. Because I don't want them messing with, I don't think they will, but they might mess with your program. Because we're going to be writing programs. They're going to be saved on your calculator. Okay? Now, I made a mistake when I let you put 0, 0 in the bottom left corner. But I'll let you do that anyway. but you're just gonna need to modify some things ahead of time to be able to view the picture. So, looking at, everybody get your calculator. And look at the back of the list of points and lines. Anybody know what I'm looking at? Back of that, yes. It says create a program at the back on the bottom. To create program. You have that? You got it? You got it? You need this? Okay. Good. Don't follow it yet. I want to show you. You got yours? You got it? Where's yours? Where's yours at?
I didn't know what to call them. Because I have to have at least 50 points.
Here's your stuff.
Because you said like you pick points.
Thank you.
All right. So on your calculator, try to stay with me. We'll create yours all together. You're gonna, yeah, you can do this. All right, so second plus 712. It'll clear out the ramp. Make sure you write down on your paper somewhere what calculator number you have, because you're going to get that one every single time. If you don't like it, get a different one. Okay? No. Why is this?